In the previous video, I welcomed you to Ethernet, and I mentioned how it is both a data link and physical layer technology. In this video, we're going to focus primarily on those physical layer connections. How can we get devices connected to an Ethernet network? We'll look at the network cards themselves, and we'll look primarily at Ethernet cabling, which is by far the most popular type of cabling that we can use. And then we'll focus in on the two types of Ethernet cables, straight through and crossover. If you want to be able to communicate on an Ethernet network, you have to get connected. I don't know if you've seen The Matrix, but it's going to be required for Cisco certification soon enough. Just kidding. But in The Matrix, all these people are jacked into this electronic world, and they all have this connector on the back of their skull, where if they want to jack into the Matrix, they shoot this I don't know, this metal thing into their head, and everybody is jacked in. It's like the industry standard Matrix connector. If you want to get in, you have to have one. In the same way, every device that's on your network has to have an industry standard connector that's compatible with Ethernet. Now, over on the left-hand side, I have a view of a PC, and I like that view because it shows both the new way of connecting to a network and the old way. It's actually probably a fairly old network card that you're seeing in the picture. The one on the left represents a ThinNet, T-H-I-N, ThinNet connection. And that was back in the day when we had ThinNet and ThickNet cables. We would literally have these baseball bat-sized cables running through the ceiling. Those are the ThickNet. And we would tap those with vampire taps. Did I mention this earlier? I might have. Little vampire taps that tap into the shielding of those and drop down little coax ThinNet cables to the PCs down here. Nowadays, we use these over here, which is just a transceiver. That is where you can plug in your Cat5 unshielded twisted pair cable. That is your matrix connector to Ethernet standards nowadays. Now, over on the right-hand side, I have a switch, and that is a picturesque picture of what your switch should look like. Although I will tell you, most IT rooms do not look like that. They will look like spaghetti, just cables thrown every which way. And I'll tell you, one of my favorite things to do when I'm consulting is just take a day, a full day, to unplug everything and recable it with Velcro just so it looks like what you see on the screen right there. That is the proper way to connect to a switch. And you know what's funny? You want to see how anal I am? As soon as I saw that picture, you know what my eyes went to? This right here. Hang on, let me grab my pen. This. You see that? That is a cable that is not in the Velcro bundle. As a matter of fact, that whole bundle right there, it's laziness, my friends. Laziness. There's no Velcro around that. It won't be long before that room turns to spaghetti. But that's all the industry standard connectors that plug into that switch. All typically Cat5 Ethernet. Now down below you see a router. Router typically has WAN connections and Ethernet connections. All of this is a standard base connections. Everybody speaks the same language and they're all plugging in the same network type. Now I've been taking for granted the entire series up to this point that you guys knew what Cat5 and things like that mean. It's almost impossible for me to talk without saying Cat5 or Cat5 on UTP. This is where I want to define those standards specifically. You can see over on the left-hand side, Category 5 unshielded twisted pair cable. This is by far the most popular cable standard that people use to connect to the network. The maximum distance one of those cables can go is 100 meters. So I can have a PC 100 meters away from the switch, which may be communicating to a server up to 100 meters away from that switch as well. So the switch acts as kind of a repeater for that signal in the middle. But that is Category 5 unshielded twisted pair. They have had different categories like Cat 1, Cat 2, Cat 3. That was a big standard cable. And as you increase in categories, you really increase in grades, like better and better grades. And technically, inside of this cable, the higher category you go, the more they actually twist the 8 pairs or 8 individual wires inside of that cable together tighter and tighter and tighter. Because the tighter the twists and the more twists there are, the better signal strength you're going to be able to get and the better and more resistant your cable is to interference. Now I do want to mention a warning. There is a category standard known as Cat 6 cabling. And you can go to any store and find in shrink wrap packages Cat 6 cable every which way. Cat 6 never really reached, and I'm speaking to this day, it may reach eventually a standardization, but it never reached industry approval. And what that means is a lot of devices will have trouble with Cat 6 cable. Typically older devices, maybe like 3, 4 years old, but there's still a lot of those kinds of devices that are out there. Switches, network hubs, things like that. And when you plug the Cat 6 cable in, the difference is these pins up top here are like very, 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 very tinily different than the Cat 5. Now, on some devices, the difference won't really matter. It'll be like, okay, that'll be fine for us. But on some other devices, typically higher end devices where they're really precise as to how far apart these pins are, Cat 6 cables causes connection problems. Like if you wiggle it, it'll end up losing connection and things like that. So my recommendation is to buy Cat 5e. That is the official standard as of right now. Cat 5e cable wherever you go. Now, down below, you see the two different styles of fiber cable. Fiber also works with Ethernet technology and recently has become very easy to work with for the most part. Well, let me back that up. Back up. They have released fiber optic standards that are very easy to work with, meaning you and I can go to the store and buy some fiber cable and run it ourselves through the walls. Most of the time when we're doing that, we're working with multi-mode fiber. That is where you have multiple light signals that can be sent simultaneously down that fiber strand. Now, it sounds like a better standard than single mode. I mean, just the name, you think, oh, well, multi is better than single. But really, it's not. It doesn't get as much distance, and it's not as clean a signal as the single mode fiber. But it is much easier to work with, and the connectors are much cheaper. You have a much lower cost connector and much lower cost equipment that you can use for multi-mode fiber. Single mode fiber is typically very difficult to work with, meaning a lot of times it takes specialized technicians. You have a pure glass core many times. The cable inside of it is glass, so if you bend it wrong, you can snap it inside and break it. But the distance can actually go much further than multi-mode. They've actually got some single mode fiber that's running between states in the United States of America. So you're looking at hundreds of miles that this can go. Now the connection type is where it comes in. The connection really is based on what kind of equipment you have. It also takes much more expensive connectors for single mode fiber in order to connect. And you can see on both multi-mode and single mode, the connection type varies. And that's a little frustrating because many different vendors including Cisco, create their own little proprietary connectors where you have to buy the connectors from them in order to connect to their equipment. I'm foreseeing somewhere down the road there's going to be an industry standard connector that everybody uses, kind of like our RJ45 is for Cat 5e. But as of right now, fiber is still too new to have the same connector used everywhere. While fiber optic cable is becoming more and more popular, I would still say 95% of what you deal with on a day-to-day basis will be Cat 5 unshielded twisted pair. Now, it's almost a rite of passage as a network technician to have to crimp cables. I've crimped hundreds of cables, and I've had my fingers callous over to do this. But when you're crimping a cable, this is the process. Well, let me back up. You can purchase cables either pre-made or crimp your own. The advantages of pre-made is typically they're tested and they're secure cables, and you don't have to crimp them. You can just buy them from the store. But they are more expensive, and you cannot get the custom cable lengths like you can with your own cable. So you can go to the store and just buy a 1,000-foot spool of Cat 5 UTP and get a crimper and get some tips, and you're good to go. The first step in crimping cables is to separate your 8 individual wires into strands. And believe it or not, this is where most of the calluses happen because these are very tightly twisted together and you have to take your fingernail and separate them out into individual wires to where you have 8 individual colored wires. The second step is to arrange those wires in a standard. Now I'm going to talk about those standards on the next slide, but for now I'll just say arrange them in the standard. There are certain ways that you should have the colors lined up. Slip one of the tips on it. If you have one of those plastic connectors like you can see down here at the bottom, you can go ahead and say, well, I would like, to put this little plastic coupler to protect the clip on the cable on there, and then crimp them. By the time it's said and done, you have a finished Ethernet cable. I mentioned arranging those wires into a standard, or arranging the colors into a standard. Here they are. These are the Ethernet standards that you can use: T568A and T568B. Nowadays, the more popular standard to use all over the place is T568B. So what you would do is grab your wires and you would say orange stripe orange, green stripe blue, blue stripe green, brown, well, it's typically brown stripe brown, but it looks a little reddish there. And there are some cables that use red connectors, but it's typically brown stripe brown is the last one. If you choose to crimp that standard on one end of the cable and then crimp the same standard on the other end of the cable, you have a Cat5 UTP cable that will go 100 meters in length. And this brings up a good point. If you choose to create your own standard, like say I want to do blue, blue stripe, green, green stripe, orange, orange stripe, and brown, brown stripe, and just put them all in that order, well, I've created my own standard. The problem is it will not go 100 meters. It'll work, but it'll be a much shorter distance than the cable can go because they're arranged inside to spin the electricity. Look at these wires inside of the cable twist and turn around each other like this, and as the electricity is sent over the wires, it creates this electromagnetic field. And we're getting into stuff that's beyond my knowledge, but it's a field of resistance that resists interference. And if you don't have them crimped in this style, that field will not form and the cable will not go anywhere near as long as it should. So crimping 568B on one end and 568B on the other end will give you a straight through cable that goes 100 meters. 568A is the other standard, and you can crimp A on one end with these colors, A on the other end with these colors, and you also have a straight through cable that will go 100 meters in length. If I were to take T568A on one end of the cable and crimp that, and then choose to do T568B on the other end, I will have created a crossover cable that can go 100 meters in length. So when would I use either one, straight through or crossover? Well, straight through is used anytime you want to connect unlike devices, or I usually think of it as things that are meant to be directly connected together. We've got a PC plugging into a switch. That is an unlike device that will use a straight through connector. I've got a router plugging into a hub or a router plugging into a switch. Those are unlike devices, so they'll use straight through connections. Like devices use crossover. Like, for example, if I were to take a PC and connect it directly to another PC without a switch or a hub in between them, that is like devices, and we need a crossover cable to make that happen. A lot of people actually call that a null modem cable. If you look at the top, we have a router back-to-back connected with another router. Usually you would have a switch in between the two, so that's kind of an unnatural connection, or like devices, so we use a crossover. A switch directly to another switch, or even a switch to a hub, those are considered like devices, so those would use crossover. You'll want to get used to recognizing on a network diagram where the different cables would be used. Would I use a straight through cable or a crossover cable when connection? Because if you use the wrong one, you won't get any link whatsoever. The last thing I want to wrap up with is how cabling looks in the real world. Because typically, yes, you will use Ethernet cables all over the place, but you won't have PCs that just run this long cable to the switch. What usually happens is you will have wall jacks installed. Either you will install them or somebody else will. Now that wall jack, if you unscrew it and take it off the wall, it will actually have these little connectors inside of it. Now this connector will take the 8 wires from that Ethernet cable and plug each one of those 8 wires into these metal connector. To do that, you'll use a tool that looks like this. Most people call that a punch down tool, where you will take the cable or the wire and lay it on there. You push that punch down tool on it, and it actually cuts off the extra wire so you don't have wires dangling off, and pushes it down to essentially wrap around or link into that metal to where it makes a solid connection. Once you've got all those crimped in there or punched down, you'll slide that connector into the plastic plate, and that's where you connect your cable to that will run into the PC. Now behind that, off of this little connector, the cable will run up through the ceiling, through the walls, and this is where you get into some construction sometimes, running up and down walls, and eventually we'll reach this thing that we call a patch panel. Now, what this is an intermediary device in between them that allows for easier connections. What you'll have is on the back, you'll take that wire, strip it back into the 8 individual wires. This is your Cat5 cable with the shielding on it. This is with it off. And you'll use your punch down tool again to punch those 8 wires onto this. A lot of people call this a punch down block. And on the front of that, you'll have all of these Cat5 connectors that are coming out of that punch down block. And from there, you'll use what people call patch cables, just short little cables to connect from that patch panel to the switch. Now you might wonder, well, why do you have this patch panel in between? Why don't you just, save a crimp and save an extra thing and just run that straight to the switch without the patch panel? Well, the reason we have that is because a lot of times our switches will move, or we'll want to move our cables from one switch to another. And if we've just run it straight to the switch, then typically the cables are just long enough to make it there. And if we want to move to a switch that's, say 10 feet away, you kind of start pulling and yanking on those cables and they don't reach and you've got things stretched and it's just ugly. So instead of doing that, they say, well, let's permanently terminate all the cables here. Then we can just connect another patch cable that can be whatever length we want and plug that into the switches that we want to plug them into. So a lot of companies, and it's a good design, will have patch panels in between to allow for those simpler connections. That is physically how Ethernet cabling works. So just to hit the high points, we saw, number one, a view of network cards on the PC and Cisco devices. It's like the Matrix. Everybody's got that standard connector where they can plug in and communicate on that network. Down below, we saw the Ethernet cabling specifically. We saw stripping it off the shielding, like you can see in that picture over there on the right, the 8 individual wires and the standards that we can crimp it to and how to crimp those wires together. We finally looked at the 2 different types of Ethernet cables, which is straight through and crossover. Straight through typically used to connect unlike devices, or in my mind, things that are meant to be connected together. A PC to a switch to a router to a hub. Those kind of things are natural connections. If you have like devices, or in my mind, things that typically don't connect directly together, you have to make a modification, and that's where the crossover comes in. Really, technically behind the scenes, the crossover just switches the send and receive pairs between the one end and the other. That's why we use the 2 different standards. So when one sends, the other one will receive it on its receive connectors on that cable. But that is connections like PC to PC, router to router, switch to switch, things that you don't usually connect directly together, and that's where the crossover cable makes it happen. I hope this has been informative for you, and I'd like to thank you for viewing.